Good day everyone, and welcome to where we are putting together solutions to those additional mathematics questions. In this video, we will be looking at the section 2 of the syllabus, coordinate geometry, vectors, and trigonometry. We'll be specifically looking at the 5 years past paper questions from May 2017 until 2022. Let's recall that in 2020, there was no paper 2 due to the pandemic. Don't forget to like the video and add any comments down below so we can help create other videos for you. Have a look at the description down below where we have outlined the order we suggest to go through the entire additional mathematics syllabus to get a better grasp of what's happening. Let's now look at the 4 major sections in additional mathematics, and we'll be looking specifically at section 2, coordinate geometry, vectors, and trigonometry. This can be subdivided into coordinate geometry, which is made up of finding the equation of a straight line and its gradient, parallel lines and perpendicular lines, the equation of a circle, its center and radius, equations of a tangent and normal to the circle, finding the points of intersection of two straight lines, just as in the CSEC Maths syllabus, and also finding the point of intersection between a straight line and the circle. For vectors, this can be subdivided into 2D vectors and their geometric representation, equality and unit vectors, position and displacement vectors, modulus and direction of a vector, scalar or dot product of two vectors, and parallel and perpendicular vectors. In trigonometry, this is broken up into finding the arc length and areas of a sector, sine, cosine, and tangent ratios of the angle 0, pi on 6, pi on 4, pi on 3, pi on 2, 2 pi on 3, 4 pi on 3, and 2 pi. Compound angle formulae, double angle formulae, trigonometric equations including graphs. As we look at the past paper questions, we can see that coordinate geometry was tested in the first part of number 3, vectors in the second part, and trigonometry in number 4 for the years May 2017, 18, and 19. As there was a change in the format from May 2021 onwards, this section came as one question. So coordinate geometry in 2021 and 2022 was tested as 3A, vectors as 3B, and trigonometry as the last part of number 3. May 2017, number 3A. A circle C has an equation x squared plus y squared plus 4x minus 2y minus 20 equal to 0. Part 1. Express the equation in the form x plus f squared plus y plus g squared equal to r squared. So let's rewrite the equation, putting the x's together and the y's together. So that will give us x squared plus 4x plus y squared minus 2y minus 20 is equal to 0. And if we look at the x values and try to complete the square, so what we'll do is take the coefficient of x, which we have in red, and find half of it. So we're going to add the square of that and minus the square of that. We've done completing the square already in section 1. So that will give us x squared plus 4x plus 2 squared minus 2 squared. So we're adding 2 squared and we're minusing 2 squared, so we're not changing the value of the equation. Plus y squared minus 2y, and we have the coefficient of the y in green. So we can see that minus 2 is what we're going to manipulate. So we're going to add minus 1 squared, half of the green term, minus 1 squared. Minus 20 is equal to 0. And let's keep the first 3 terms together, x squared plus 4x plus 2 squared, minus 2 squared, so we put some brackets there. Similarly for the y terms, plus y squared minus 2y plus minus 1 squared minus 1 squared minus 20. So the first 3 terms can be written as x plus 2 all squared minus 4 plus the next three terms can be written as y minus 1 all squared minus 1 minus 20 is equal to 0. So we can rewrite it x plus 2 squared plus y minus 1 squared, and minus 4 minus 1 is minus 5, minus 20 is minus 25, and if we carry it across, it will be equal to 25. So it's now rewritten into the form. Part 2. State the coordinates of the center and the value of the radius of the circle. So since we have x plus 2 squared, it means that the x coordinate at the center is minus 2. And we have y minus 1 squared, and the y coordinate at the center will be 1. So the center is minus 2, 1. We can bring that up in a little sketch there. And on the right hand side, r squared is equal to 25, which means r, the radius of the circle, is equal to 5. So we can bring up the circle so we can see what it looks like. Part 3. Determine the points of intersection of circle C and the equation y is equal to 4 minus x. So if we bring up a sketch, we can see that black line cutting the circle at a couple points. So let's rewrite the equation x plus 2 squared plus y minus 1 squared is equal to 25. That came from part 1. And we can substitute for y, because y is equal to 4 minus x. So that will give us x plus 2 squared plus 4 minus x, because that's y, minus 1 squared is equal to 25. So x plus 2 squared plus 4 minus 1 is 3 minus x squared is equal to 25. And we can expand. So it'll give us x squared plus 4x plus 4 plus 3 minus x squared is 9 minus 6x plus x squared minus 25 is equal to 0. We'll bring the 25 across. So we can now simplify. It will give us x squared plus x squared is 2x squared plus 4x minus 6x is minus 2x plus 9 plus 4 is 13 minus 25 is minus 12 is equal to 0. And we can solve as is using the quadratic formula, or we can divide by 2. So it will give us x squared minus x minus 6 is equal to 0. And we can factorize, so that will give us x minus 3 by x plus 2 is equal to 0. So either x minus 3 is equal to 0, which implies x is equal to 3. And when x is equal to 3, and we can substitute into the equation y is equal to 4 minus x, so y is equal to 4 minus 3, so y is equal to 1. As such, one point of intersection would be 3, 1. And we can bring that up so you can see it. Or x plus 2 is equal to 0, which means x is equal to minus 2. And y is equal to 4 minus x, so we can substitute in here. It'll give us y is equal to 4 minus minus 2. 4 minus minus 2 is 4 plus 2 is 6. So the second point of intersection is minus 2, 6. So we can see on the graph where we have the center, we have the radius of 5, and we have the points of intersection of that straight line with the circle. May 2017, number 3b. Given that p is equal to 2i plus 3j, so let's make a little sketch. Let's bring up the origin, and we're using that position vector, 2i mirroring 2 to the right, and 3 up, 3j. So we can average where p is. And q is equal to I plus 5j. So we can average that q is 1 unit to the right and 5 units up. So let's bring up a line for that as well. Part 1. The product of the two vectors p and q. So let's use the scalar product or dot product. So p dot q is equal to 2, 3, because p is 2i plus 3j, dot 1, 5. Because q is 1i plus 5j. The 1 is understood. Notice we have it in different colors, so we're going to multiply the red term by the black term, the first term in p by the first term in q, so that'll be 2 times 1, plus the second term in p, which we have in green, times the second term in q, so 3 times 5. We use the color, so it's easy for you to identify how to do the dot product. So that gives us 2 1s are 2, plus 3 5s are 15. As such, p dot q is equal to 17. Part 2. The angle between the two vectors. So if we're using p dot q is equal to mod p, mod q cos theta, where mod or modulus of p and q are the lengths. Remember, this is a formula given in the formula sheet. Then in order to work out the angle theta, we must know everything else. We know P dot Q is equal to 17. We worked that out already in the first part. But we don't know the lengths of P and the lengths of Q. So there are a couple of different ways to do this. One way would be to bring up a triangle for P. Let's have it in light blue. And what can we tell? That in order to find the length of P, we need to know the change in X, which works out to be 2 because it's 2i, and the change in Y is 3 because it's 3j. So using Pythagoras' theorem, the length of P would be 2 squared plus 3 squared, the square root of that. So 2 squared is 4 plus 3 squared is 9. So we've got 9 and 4 is 13. So mod P, or the length of P, modulus P, is equal to square root of 13. And similarly, so let's bring up a green right angle triangle to show the vector Q. And we know the change in X is 1 because it's 1i. And the change in Y is 5 because it's 5j. So using Pythagoras' theorem, then the length of Q would be 1 squared plus 5 squared, the square root of that. So 1 squared is 1 plus 5 squared is 25. 1 plus 25 is 26. So the length of Q is square root of 26. So we can now substitute, and that will give us 17 is equal to square root of 13 times square root of 26 cos theta. As such, we can find for cos theta, which will be 17 divided by square root of 13 by square root of 26. So theta works out to be 22.38 degrees. So that will be the angle between the two vectors. May 2017, number 4a, figure 1 shows a plot of land ABCD, not drawn to scale. Section ABC is used for building and the remainder for farming. The radius BC is 10 meters and angle BCD is a right angle. So we can see that in the diagram that BC is the same length as AC, which is 10 meters, which is the hypotenuse of that right angle triangle. Part 1. If the building space, which is ABC, is 50 pi on 3 meters squared, calculate the angle ACB in radians. So we want to find theta. So the area of a sector, ABC, is equal to half r squared theta. And we know the area of a sector and we know the radius, so we can find theta. So let's substitute. 50 pi on 3 is equal to half times 10 squared theta, because the radius is 10. So 50 pi on 3 is equal to 10 squared is 100, a half of 100 is 50 theta. So if we carry the 50 across and we divide, then theta is equal to pi on 3 radians, which of course is equal to 60 degrees. Part 2. Working in radians, calculate the area used for farming. Let's consider that the angle ACB theta is equal to the angle DAC because they're alternate interior angles. As such, if we want to find the area used for farming, that will be the area of ACD is equal to half AD times CD, because the area of a triangle is a half length times breadth, or base times height, as long as there's an angle of 90 degrees between them. So we know AC, so let's substitute accordingly. So area of ACD is equal to half AC cos theta, because AC cos theta is AD, the adjacent, times AC sin theta, which gives us the opposite. So one gives us the base and one gives us the height. And if we substitute, because we know AC is 10, then that's going to give us a half times 10 cos pi on 3 by 10 sin pi on 3, which works out to be, using our calculators, 21.65 meters squared. Part B. Given that sin pi on 3 is equal to root 3 on 2, cos pi on 3 is equal to a half, and sin pi on 4 is equal to cos pi on 4, which is root 2 on 2. Show, without using a calculator, that cos pi on 4 minus pi on 3 all over sin 2 pi on 3 is equal to root 2 plus root 6 all over 2 root 3. So let's take the left-hand side, which is equal to cos pi on 4 minus pi on 3, cos sin 2 pi on 3. And these are two formulas given in the formula sheet as compound angles. Remember, cos A minus B is cos A cos B plus sin A sin B. So let's look at the numerator. It will give us cos pi on 4 cos pi on 3 plus sine pi on 4, sine pi on 3. And also the compound angle formula is given for sine, and that's a double angle formula. So sine 2 pi on 3 is really sine 2 theta. So it'll be 2 sine pi on 3 cos pi on 3. And if we substitute, that will give us root 2 on 2 times a half plus root 2 on 2 times root 3 on 2. All over 2 times root 3 on 2 times a half. And if we simplify, it's going to give us root 2 on 4 plus root 6 on 4 divided by root 3 on 2. So we can simplify and find the reciprocal of the denominator. So that gives us root 2 plus root 6 all over 4 times 2 over root 3. And 2 can cancel, so we're going to be left with root 2 plus root 6 all over 2 root 3. Because 2 into 2, 1, 2 into 4, 2. Which is equal to the right hand side. As such, we have completed the proof. May 2014, number 4C. Prove the identity 1 minus cos squared theta over 1 plus sine theta is equal to sine theta. So let's recall the left hand side, which is 1 minus cos squared theta over 1 plus sine theta. And my students have found it easier if we use the more complicated side and try to simplify it. And of course, we know cos squared theta is 1 minus sine squared theta, so we can replace it. So that will give us 1 minus sine squared theta over 1 plus sine theta. And that numerator, 1 minus sine squared theta, looks like the difference of squares. So we can rewrite it 1 minus sine theta by 1 plus sine theta all over 1 plus sine theta. 1 plus sine theta in the numerator and denominator, so we can cancel. So that we'll be left with 1 minus sine theta. And if we distribute the minus 1 across the brackets, it'll give us 1 minus 1, which is 0, plus sine theta. So we'll be left with sine theta, which is equal to the right hand side. As such, we have completed the proof. May 2018, number 3A. Determine the equation of the circle that has center 5 minus 2. So let's bring up some axes to make a little sketch and bring up 5 minus 2, meaning that it'll be in the fourth quadrant and passes through the origin. So we know the center of the circle, and 1 point on the circle's circumference is the origin. So we can bring up that, and let's draw a dotted line to show the circle. So if we want to find the equation of the line, remember the general formula given in the formula sheet is x plus f squared plus y plus g squared is equal to r squared. So we need to find the radius squared. So if we bring up a right angle triangle, we have that in blue, to move from the circumference to the center. So if we're moving from the origin, we want to go 2 units downward, so the change in y is minus 2. And we want to move 5 units to the right, so the change in x is 5. Using Pythagoras' theorem, change in x squared plus change in y squared is equal to r squared. So it is going to give us 5 squared plus minus 2 squared is equal to r squared. 5 5s are 25 plus minus 2 by minus 2 is 4. 25 plus 4 is 29. So 29 is equal to r squared. So we can now substitute into the equation because we know what f is and g, because those are from the coordinates of the center. So we're going to get x minus 5 squared plus y minus, what's the y coordinate of the center? Minus 2. So y minus minus 2 squared is equal to 29. So that gives us x minus 5 squared plus y plus 2 squared is equal to 29. And we can expand and simplify. So it's going to give us x squared minus 10x plus 25 plus y squared plus 4y plus 4 is equal to 29. And we can move everything across to be equal to 0. So it's going to give us x squared minus 10x plus y squared plus 4y. And we have 25 plus 4 is 29. We have 29 minus 29 is equal to 0. Part B. Determine whether the following pair of lines is parallel. X plus y is equal to 4. Let's call that equation 1. And the 3x minus 2y is equal to minus 3. Let's call that equation 2. So if we look at equation 1 and try to manipulate it to make y the subject of the formula, which will be the general formula for straight line, Then it's going to give us y is equal to minus x plus 4. And the number in front of the x is the gradient. So the gradient of this first line, m1, is equal to minus 1. Let's do the same thing with the second equation. So in transposing, it'll give us 3x plus 3 is equal to 2y. So y is equal to 3 on 2, x plus 3 on 2. So the gradient of the second line, which is the coefficient of x, is 3 on 2. Since the gradient of the first line, m1, is not equal to the gradient of the second line, the lines are not parallel. May 2018, number 3c. The position vector of 2 points A and B relative to a fixed origin O are given by OA is equal to 2i plus j. So let's bring up a little sketch so we can get an idea of what's happening. We know O is the origin and A is 2i plus j. So it will be in the first quadrant. So you can bring up A and we'll draw a line to show that. And OB is equal to 3i minus 5j. So it's 3 units to the right and 5 units down. We're just averaging where B is, where I and j represent unit vectors in the x and y directions respectively. Calculate, part 1, the magnitude of AB. So we want to find the length of AB. First of all, we need to work out the vector. So how do we go from A to B? We would like to travel from A to O and then O to B. But we don't have AO, we have OA, which will be, it will be the exact vector in the opposite direction. So how do we represent that? We say AB is equal to minus OA plus OB. And we can substitute, which will give us minus 2, 1, because AB was 2i plus j, plus 3 minus 5. And minus 2 plus 3 is 1, minus 1 plus minus 5 is minus 6. So AB, that vector, would be 1 minus 6. Meaning to go from A to B, we need to move 1i, or 1 unit to the right, minus 6j, and 6 units downwards. So if we want to find the length of AB, let's bring that up with a blue triangle. This right angle triangle will help us to represent the length using Pythagoras' theorem. And we know the change in the x to move from A to B is 1. Delta x is equal to 1. And change in y is minus 6. So that will give us 1 squared plus minus 6 squared, which works out to be 1 ones are 1, plus 6 sixes are 36. 1 plus 36 is 37. AB squared, 37. As such, the length of AB, or mod AB, is equal to the square root of 37 units. Calculate, part 2, the angle AOB, giving your answer to the nearest whole number. So using scalar product, OA dot OB is equal to mod OA dot mod OB cos theta. This is given in the formula sheet. And let's recall, mod OA means the length of OA by the length of OB. And let's work that out. So let's look at OA. To move from O to A, using the similar processes that we did in part 1, we need delta x squared plus delta y squared using Pythagoras' theorem. So OA squared is equal to 2 squared plus 1 squared, because it was 2i plus j. So 2 2s are 4 plus 1 is 5. So OA, the length will be the square root of 5. So now let's bring up a triangle for OB. Similarly, OB would be equal to 3 squared plus minus 5 squared, which works out to be 9 plus 25 is 34. So OB, the length of that will be the square root of 34. We can now substitute into there to find for theta. So 21.3 minus 5 is equal to square root of 5 by square root of 34 cos theta. And how do we get OA dot OB? Well, we multiply the first term in OA by the first term in OB. So it'll be the red term, which is 2, times the black term, which is 3. We're using the colors so students can easily identify what's happening. Plus the green term, which is the second term in A by the second term in B. The green term by the blue term, so 1 times minus 5. So 2 3s are 6, plus 1 times minus 5 is minus 5. 6 minus 5 is 1. So 1 is equal to the square root of 5 by the square root of 34 cos theta. So if you want cos theta, it'll be 1 divided by root 5 root 34. As such, we can use our calculators and work that out and find arc cos or cos inverse. So theta is equal to 86 degrees. Remember, we had to round off our answer because we wanted our answer to the nearest whole number. So the angle between OA and OB would be 86 degrees. May 2018, number 4A. A wire in the form of a circle with radius 4 centimeters, as we can see in the diagram there, is reshaped in the form of a sector of a circle with radius 10 centimeters. So we're taking the same wire and we're reshaping it. Determine in radians the angle of the sector, giving your answer in terms of pi. So if we compare the diagrams on the left and the right, by reshaping it, what remains the same will be the length of the wire. So let's consider the length of the wire in the diagram on the left in the circle. That is known as the circumference. So circumference is equal to 2 pi r, which is equal to 2 pi times 4. 4 2s are 8, so circumference is equal to 8 pi units. And since the length of the wire remains the same, it means the perimeter of the sector will be the same as the circumference of the circle. So the perimeter of the sector is equal to r, the radius, plus r theta. And if we substitute, it's going to give us 8 pi, because that's the circumference, is equal to, what's the radius? 10 plus 10 plus 10 theta. So we can find for theta. So 8 pi minus 20 is equal to 10 theta. As such, theta is equal to 8 pi minus 20 all over 10. Or we can divide by 2 throughout. So it's going to give us 4 pi minus 10 all over 5 radians. Part B. Solve the equation sine squared theta plus 3 cos 2 theta is equal to 2. For 0 is less than or equal to theta, which is less than or equal to pi, to 1 decimal place. So let's rewrite the equation. Sine squared theta plus 3 cos 2 theta is equal to 2. We know cos 2 theta, so let's substitute for that. So it's going to give us sine squared theta plus 3 by 1 minus 2 sine squared theta minus 2 is equal to 0. So we can expand. So it's going to give us sine squared theta plus 3 1s are 3 minus 3 2s are 6 sine squared theta minus 2 is equal to 0. And if we simplify, 3 minus 2 is 1. 1 and 1 sine squared theta minus 6 sine squared theta is minus 5 sine squared theta is equal to 0. So we have one unknown, which is theta, so we can solve for that. So 1 is equal to 5 sine squared theta. So 1/5 is equal to sine squared theta, carrying the 5 across. So sine theta is equal to plus or minus the square root of 1/5. Either sine theta is equal to plus 1 over root 5. So theta is equal to 26.6 degrees and 153.4 degrees. Or sine theta is equal to minus 1 on root 5, which indicates that theta is equal to 206.6 degrees and 333.4 degrees. But if we look at the range, theta has to be from the first two quadrants, from 0 to pi. As such, the answers for theta are 26.6 degrees and 153.4 degrees. Part C. Prove the trigonometric identity 1 on 1 minus sin x minus 1 over 1 plus sin x is equivalent to 2 tan x cos x. So we can use either side to solve this. So we use the left-hand side, which is equal to 1 over 1 minus sin x minus 1 over 1 plus sin x. So if we subtract two fractions, that will give us 1 plus sin x minus 1 minus sin x all over 1 minus sin x by 1 plus sin x. If we remove the brackets, it will give us 1 plus sin x minus 1 plus sin x all over 1 minus sin squared x, because the denominator is the difference of squares. So the numerator simplifies to 2 sin x, and the denominator 1 minus sin squared x is equal to cos squared x. So we can separate it, so it will give us 2 sin x over cos x times 1 over cos x, and sin x over cos x is tan x. So that will give us 2 tan x times 1 over cos x, which is 2 tan x over cos x, which is the right-hand side. So we've proven the trigonometric identity. May 2019, number 3A. A circle with center 1 minus 1 passes through the point 4, 3. So let's bring up a little sketch showing the axes and the center, 1 minus 1. And let's put a dotted line to show the circle and the point 4,3 on the circumference. Part 1. Calculate the radius of the circle. So if we consider a right angle triangle from the center of the circle to the circumference, we can see that the change in x, we're moving from a value of 1 to a value of 4, will mean that delta x is equal to 3, and the change in y will be moving from minus 1 to 3, so delta y is equal to 4. So we can substitute into Pythagoras' theorem. Change in x squared plus change in y squared is equal to r squared, the length of the radius. So 3 squared plus 4 squared is equal to r squared. 3 3s are 9, plus 4 4s are 16. 9 and 16 is 25. So 25 is equal to r squared. As such, r is equal to 5 units. Part 2. Write the equation of the circle in the form x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. So we know x plus f squared plus y plus g squared is equal to r squared. This is a formula given in the formula sheet. And we know the coordinates of the center, which is 1 minus 1. So f will be considered as minus 1 because x minus 1 plus y minus minus 1 squared is equal to, what is r squared? 25. So that becomes x minus 1 squared plus y plus 1 squared is equal to 25. And we can expand. So that will give us x squared minus 2x plus 1 plus y squared plus 2y plus 1 is equal to 25. And if we bring everything across, it will give us x squared plus y squared plus 2 by minus 1x plus 2 by 1y minus 23 is equal to 0. Part 3. Determine the equation of the tangent at the point 4, 3. So let's bring up a tangent, a brown line passing through 4, 3. And the gradient of the normal from the center of the circle to the point at the circumference is a change in y over change in x. And we know the y value is 4 and the x value is 3. So the gradient is 4/3. And the normal and the tangent, they're supposed to be perpendicular to each other, which means that mn, the gradient of the normal, times mt, the gradient of the tangent, is equal to minus 1. And if we substitute for the gradient of the normal, it'll give us 4/3 times the gradient of the tangent is equal to minus 1. So the gradient of the tangent is equal to minus 3/4. And if we know the gradient of the tangent, that is change in y over change in x, we can substitute. So it's going to give us minus 3/4 is equal to y minus, what's the y coordinate of a point that the tangent is passing through? That is 3. So y minus 3 all over x minus 4. And we can carry the denominator across. So it's going to give us minus 3/4 times x minus 4 is equal to y minus 3. And if we expand, it'll give us minus 3/4 x plus 3/4 times 4 plus 3 is equal to y, carrying the minus 3 across. And if we simplify, it ends up that y is equal to minus 3/4 x. 3/4 times 4, 4 into 4, 1. So 3 plus 3 is 6. So y is equal to minus 3/4 x plus 6 is the equation of the tangent. May 2019, number 3b. Two vectors p and q are such that p is equal to 8i plus 2j. So let's bring that up in a sketch. And q is equal to I minus 4j, which fits into the fourth quadrant of the sketch. So these sketches are recommended to give students a better grasp of what's happening in the question. Part 1. Calculate p dot q. So we know p, 8, 2, because it's 8i plus 2j, and q is 1 minus 4, because it's I minus 4j. So if we want to find p dot q, which is 8, 2 dot 1 minus 4, notice we have them in 4 different colors, so students can easily identify what's happening. We'll be multiplying the two top terms, determined red times determined black, which will be 8 times 1, plus we'll be multiplying the two bottom terms, which will be determined green times determined blue, which is 2 times minus 4. So 8 ones are 8, plus 2 times minus 4, that's minus 8. 8 minus 8 works out to be 0. Part 2. State the angle between the two vectors p and q. So p dot q is equal to mod p mod q cos theta. That's a formula in the formula sheet. And we just worked out in part 1 what p dot q is, that's 0. So 0 is equal to mod p, the length of p, times the length of Q cos theta. And clearly from our sketch, we can see that the length of P is not 0 and the length of Q is not 0. So the only way the right-hand side can work out to be 0 is if cos theta is 0. And if cos theta is equal to 0, it means that theta is equal to 90 degrees. So let's bring up a little yellow right angle to show that, meaning that P and Q are perpendicular to each other. Part C. The position vector A is equal to 4i minus 7j. So I like to make a sketch so students can see what's happening. Find the unit vector in the direction of A. So if we want to find the unit vector, we need to find the length or the modulus of A. And in order to do that, let's bring up a right angle triangle in blue. And what does that indicate? That if we are moving to the right, delta x is equal to 4 because we have 4i, and delta y is equal to minus 7 because we're moving downwards 7. So using Pythagoras' theorem, the length squared, which is mod A squared, is equal to 4 squared plus minus 7 squared, which works out to be 4 4s are 16 plus 49 is 65. So mod A, or the length of A, is root 65. If we want to find the unit vector of A, that's the vector A divided by its length, which means that's equal to 4i minus 7j all over the square root of 65. May 2019, number 4a. A compass is used to draw a sector of radius 6 centimeters and area 11.32 centimeters squared. Part 1. Determine the angle of the sector in radians. Let's recall the area of a sector is a half r squared theta. And if we substitute, 11.32 is equal to half times what's r? 6 squared theta. So the only unknown is theta. We can solve for that. 6 squared is 36. A half of 36 is 18. As such, 11.32 divided by 18 is equal to theta. So theta is equal to 0.629 radians. And you can either write RAD or put a small c to indicate radians. Part 2. Calculate the perimeter of the sector. So this shape has 3 sides. So to find the perimeter, we can add up the 3 sides. R plus the length of the arc, which is r theta, which gives us 6 plus 6 plus 6 times what is theta? 0.629. So that works out to be a perimeter of 15.774 centimeters. Part B. A right angle triangle XYZ has an angle theta, where sine theta is equal to the square root of 5 over 5. Without evaluating theta, calculate the exact value, insert form if applicable, of part 1 cos theta. So there are a couple of ways to do this. One way is to make a right angle triangle and input the opposite, which is square root of 5, and the hypotenuse, which is 5, and work out the adjacent. Another way is as follows. Cos square theta plus sine square theta is equal to 1. So cos square theta is equal to 1 minus sine square theta. And we know sine theta, so we can substitute. So cos square theta is equal to 1 minus the square root of 5 over 5, all squared, which means 1 minus 5 over 25. And 5 over 25 is 1/5. So 1 minus 5 over 25, which works out to be 25 minus 5 is 20 over 25. So cos theta is equal to the square root of 20 over 25. Or we can say cos theta is equal to, what is the square root of 20? The square root of 4 times 5. The square root of 4 is 2, so we could pull that out. So it's going to give us 2 root 5 over 5. So sine theta was root 5 over 5. And cos theta is 2 root 5 over 5. So sine 2 theta. So sine 2 theta is equal to 2 sine theta cos theta using our double angle formula. And if we substitute, it will be 2 times root 5 over 5 times 2 root 5 over 5. So that works out to be 2 2s are 4. Root 5 by root 5 is 5 over 25. So the 5 cancels, so we're left with 4/5. So sine 2 theta is equal to 4/5. May 2019, number 4C. Show that tan squared theta plus 1 is equal to 1 over cos squared theta. and we can use either side. So let's pick the left-hand side is equal to tan squared theta plus 1. And we know tan theta is sine theta over cos theta. So we can substitute for that. So it will be equal to sine squared theta over cos squared theta plus 1. And now all we have to do is manipulate the fractions. So that's going to give us sine squared theta plus cos squared theta all over cos squared theta. And sine squared plus cos squared theta is equal to 1. So that's going to give us 1 over cos squared theta, which is equal to the right-hand side. So we've completed the proof. May 2021, number 3A. The coordinates for the center of a circle is 2, 1. So let's bring up a sketch and let's put the center of the circle there. And the coordinates for a point on its circumference is 3, 3. So let's bring up a circle. So let's bring up that point 3, 3. Remember, this is a sketch, so we're just picturing what it looks like. Determine the equation of the circle in the form x squared plus y squared plus ax plus by plus c equal to 0. So we need to find the radius, and we can bring up a right angle triangle to assist us. To move from the center to the point on the circumference, we're moving 1 unit to the right, so delta x is equal to 1, and we're moving 2 units up, so delta y is equal to 2. So if you write our quadratic formula, the length of the hypotenuse, r squared, is equal to delta x squared plus delta y squared, which is equal to 1 squared plus 2 squared, 1 ones are 1 plus 2 twos are 4, r squared is equal to 5. So let's recall our formula, x plus f squared plus y plus g squared is equal to r squared. This is a formula given in the formula sheet. And we can substitute because we know the center of the circle is 2, 1. So it'll be x minus 2 squared plus y minus 1 squared is equal to r squared, which is 5. So if we expand, it's going to give us x squared minus 4x plus 4 plus y squared minus 2y plus 1 is equal to 5. And if you bring everything across on the left-hand side, it's going to give us x squared minus 4x plus y squared minus 2y plus 4 plus 1 minus 5 is equal to 0. So x squared minus 4x plus y squared minus 2y is equal to 0. Part 2. The circle intersects the x and y axes at 3 points of intersection. Determine the coordinates of the 3 points of intersection. So let's consider where it's cutting the y-axis. And for that to happen, the x values must be 0. So if we substitute 0 into that general formula, it's going to give us 0 squared minus 4 by 0 plus y squared minus 2y is equal to 0. So y squared minus 2y is equal to 0. And if we factorize, it's going to give us y by y minus 2 is equal to 0. So either y is equal to 0, and when y is equal to 0, what does that mean? X is 0. Or y is equal to 2, and x is still 0. So the 2 points of intersection on the y-axis is 0, 0, the origin, and 0, 2. So let's shift the axes somewhat so we can follow that. So our sketch was a little incorrect, and it looks a little better now. And if we want to look on the x-axis now to find the roots, then we can substitute y as 0. So it's going to give us x squared minus 4x plus 0 squared minus 2 times 0 is equal to 0. We're still using that same equation we got from part 1. And that gives us x squared minus 4x is equal to 0. So x by x minus 4 is equal to 0. Either x is 0 when y is 0, because that's what we substituted, or x is 4 when y is 0. So it's still going to give us 0, 0, the origin, which you already have, and 4, 0, which is another root. So that gives us our 3 points of intersection. May 2021, number 3A, part 3. Determine the equation of the tangent to the circle at the point 3, 3. So let's bring back up the sketch. And we want to find the equation of the tangent. So we need to find the gradient of the normal first, or the gradient of the radius, the same thing. So that's changing y by changing x, and we know delta y is 2 and delta x is 1. So 2 over 1, so the gradient of the radius is 2. And the gradient of the normal by the gradient of the tangent will give us minus 1 because they are perpendicular to each other. 2 times the gradient of the tangent is equal to minus 1. As such, the gradient of the tangent is minus a half. And we can tell that from the brown line that the gradient is negative. So the gradient of tangent is equal to change in y over change in x, and we can substitute using the x and y coordinates of a point passing through the tangent. So we can substitute 3, 3, which is a point on the tangent. So it gives us minus a half is equal to y minus 3 over x minus 3. And if we carry the denominator across, it will give us minus a half by x minus 3 is equal to y minus 3. And if we make y the subject of the formula, it's going to give us minus a half. Minus a half by minus 3 is plus a half by 3 plus 3. And if we simplify, y is equal to minus a half x plus 9 over 2. So that's the equation of the normal. May 2021, number 3b. The position vectors of 2 points P and Q relative to origin O are given by OP is equal to 2 minus 3. So let's bring up O, and there's a general idea where P will be to the bottom right. And OQ is minus 4, 1, and it will be to the top left because we're moving 4 units to the left and 1 unit up. So we just have a general sketch for students to follow. Determine the unit vector in the direction of PQ. Let's go from P to Q, draw a red line, giving your answer in its simplest form. How do we go from P to Q? We can go from P to O plus O to Q. And we have the negative of PO, which is minus OP. So we can substitute minus OP plus OQ, which is equal to minus of 2 minus 3 plus minus 4, 1, which is given above. And that works out to be minus 2 plus minus 4 is minus 6. Minus minus 3 is 3 plus 1 is 4. So PQ would be minus 6, 4, meaning we're moving 6 units to the left and 4 units up to go from P to Q. And you can see that general idea is happening there. So if you want to find the unit vector, then we want to find the length of PQ. So the modulus of PQ, or mod PQ, we can use a right angle triangle in order to use Pythagoras' theorem, where the length of PQ will be the longest side. So mod PQ squared is equal to delta x squared plus delta y squared, which is minus 6 squared plus 4 squared. And 6 squared is 36 plus 16 is 52. So the length of PQ is mod 52. So the length of PQ is the root of 52. And we know 52 is 4 times 13. So we can say square root of 4 times square root of 13 is 2 times root 13. As such, we can say the unit vector of PQ is the vector PQ over its modulus, which is minus 6i plus 4j over 2 root 13. We can leave the answer as is, or we can rewrite it by dividing throughout by 2. So this will give us minus 3i plus 2j all over root 13. That will be the unit vector of PQ. Part C. Given that cos M is equal to 24 and 25, and that angle M is acute, so we can bring up a little sketch showing a right angle triangle where the adjacent is 24, the opposite is O, we don't know, but we know the hypotenuse is 25. Determine the value for tan 2m. So if O squared plus A squared is equal to 8 squared, we can use Pythagoras' theorem in order to work out O. Then O squared is 8 squared minus A squared, which is 25 squared minus 24 squared. So O is equal to 625 minus 576, which is 49. The square root of 49 is 7. So O, the opposite, is 7. So tan M is opposite over adjacent is 7 over 24. And if we want to find the double angle formula, tan A plus B is tan A plus tan B over 1 minus tan A tan B. And if A and B are the same, let's call them M. So tan 2M is 2 tan M over 1 minus tan squared M. This is given in the formula sheet. So if we substitute, tan 2m is equal to 2 by what's tan m? 7 over 24, all over 1 minus 7 over 24 squared. And 2 times 7 is 14 over 24, multiplied by the reciprocal of the denominator, which is 24 squared, which is 576, over 576 minus 7 squared, which is 49. So using our calculators, we can simplify, and that will give us 336 over 527. May 2022, number 3a. The equation of a circle is x squared plus y squared plus 4x minus 8y plus 10 is equal to 0. Part 1. Determine the coordinates of its center and the length of the radius of the circle. So, x squared plus 4x plus y squared minus 8y plus 10 is equal to 0. We're just rewriting it a little bit, keeping the x's together and the y's together. And if you notice, I've highlighted the coefficient of x, which is plus 4 in red, and that of y, which is minus 8. And this is to help us to basically complete the square and find the center. So x squared plus 4x can be rewritten as x squared plus 4x plus half of 4, which is plus 2 squared minus 2 squared. So if we're adding and subtracting the same thing, that means we're not changing the actual value because it's 0. Plus y squared minus 8y plus what's half of minus 8? Minus 4 squared minus minus 4 squared plus 10 is equal to 0. And if we identify the first three terms and put that in brackets, so we're going to get an x squared plus 4x plus 2 squared. And do the same thing with y. So we're going to get y squared minus 8y plus minus 4 squared plus 10 is equal to 0. And if we factorize the first three terms, we're going to give us x plus 2 all squared minus 4 plus y minus 4 all squared minus 16 plus 10. It looks like the formula given in the formula sheet, x plus f squared plus y plus g squared is equal to r squared. So it's going to give us x plus 2 squared plus y minus 4 squared. And if we have minus 4 minus 16, that's minus 20 plus 10 is minus 10. And moved across to the other side is equal to 10. So the center is minus 2, that's the x value. And y is 4. And the radius squared is 10. So the radius is the square root of 10 units. So we can bring up a sketch showing the center as minus 2, 4 and a circle approximately with a square root of 10. Part 2. Determine the equation of the tangent to the circle at the point P, minus 5, 5. So if we bring up that point, we can see it's a little bit to the left and upwards. So let's draw the normal. And we can bring up a triangle. So if we're moving from minus 5, 5 to the center, so we're moving 1 unit downwards, so we say delta y is minus 1, and we're moving 3 units to the right. So delta x is equal to 3. As such, the change in y over change in x, which is the gradient, will be minus 1 over 3, or minus 1/3. The gradient of the normal and the gradient of the tangent, when you find the product of it, should give you minus 1 because the angle between them is 90 degrees. They're perpendicular. So minus 1/3 times mt is equal to minus 1. So the gradient of the tangent is equal to 3. And if we look at that brown line where we show the tangent, then we can see it's sloping upwards to the right. So it's positive. And if we substitute, the gradient of the tangent is equal to change in y over change in x, where 3 is equal to y minus 5 over x minus minus 5. And we got the x and y coordinates from the point on the tangent. So if we carry across the denominator, it will be 3 times x plus 5 is equal to y minus 5. And make y the subject of the formula. So let's expand the brackets. We're going to get 3x plus 3 5s are 15 plus 5. As such, y is equal to 3x plus 20 is the equation of the tangent. May 2022, number 3b. The vectors ox and oy are such that ox is equal to 4i plus j and oy is equal to I minus 4j. Show that the vectors ox and oy are perpendicular. So since we know ox, we can write that as a column vector 4, 1, and similarly oy as 1 minus 4. And we find dot product of that to get ox dot oy is 4, 1 dot 1 minus 4. And let's recall I'm putting 4 different colors so you can easily see how to find dot product. It'll be the 2 terms on top that we're multiplying, the red term and the black term. So it'll be 4 times 1 plus the 2 terms at the bottom being multiplied, which is the green term and the blue term, which is 1 times minus 4. So 4 ones are 4, plus 1 times minus 4 is minus 4. 4 minus 4 is 0. So if ox dot oy is equal to 0, and we know that is equal to the length of ox by the length of oy cos theta, clearly we can see that ox, the length of that is not 0, and the length of oy is not 0, which means the only way the right hand side can work out to be 0 if cos theta is equal to 0. As such, theta is equal to 90 degrees. So this proves that ox and oy, the angle between them is 90 degrees, or we can say OX and OY are perpendicular. Part C, the diagram below, not drawn to scale, shows a chord AB, which subtends an angle of 0.5 radians at the center O, of a circle of radius 10 centimeters. Given that the area of the triangle AOB is equal to half r squared sine theta, calculate the area of the shaded region. So the area of the shaded region is equal to the area of the sector minus the area of the triangle. So that will be a half r squared theta minus a half r squared sine theta. And we can substitute because we know r is 10 and we know theta. So the area of the shaded region is a half times 10 squared times 0.5 minus a half times 10 squared sine 0.5 radians. So that will be 25 minus 23.97. So the area of the shaded region is 1.03 square centimeters. May 2019, 3D. Part 1. Show that cos 2 theta is equal to 2 cos square theta minus 1. So let's recall the compound angle formula from the formula sheet. Cos A plus B is equal to cos A cos B minus sin A sin B. And if we let A and B both be equal to theta, then we're going to get cos theta plus cos theta is equal to cos theta by cos theta minus sin theta by sin theta. And we can simplify this, which will be our left-hand side. So cos 2 theta is equal to cos square theta minus sin square theta. And let's recall that sin square theta is 1 minus cos square theta. So cos 2 theta is equal to cos square theta minus 1 minus cos square theta, which is equal to cos square theta minus 1 plus cos square theta, which is equal to 1 plus 1, 2 cos square theta minus 1, which is the right-hand side. So we have completed the proof. Part 2. Hence, solve the equation cos 2 theta plus cos theta plus 1 is equal to 0 for the angles from 0 to 2 pi. So if cos 2 theta plus cos theta plus 1 is equal to 0, and we know cos 2 theta as 2 cos square theta minus 1, we can substitute there. So it's going to give us 2 cos square theta minus 1 plus cos theta plus 1 is equal to 0. And 1 minus 1 is 0, so we're left with 2 cos square theta plus cos theta is equal to 0. And we could factorize out cos theta. So it's going to give us cos theta by 2 cos theta plus 1 is equal to 0. So either cos theta is equal to 0, which means theta is equal to 90 degrees, pi on 2, or 3 pi on 2, or 2 cos theta plus 1 is equal to 0. So 2 cos theta is equal to minus 1, cos theta is equal to minus 1 over 2. So theta is equal to 2 pi on 3, or 4 pi on 3. As such, the solution for this equation for the range 0 to 2 pi is theta is equal to pi on 2, 3 pi on 2, 2 pi on 3, and 4 pi on 3. We have now come to the end of CSEC past paper questions in the topic of coordinate geometry, vectors, and trigonometry. In our first video in this series, we looked at past paper questions from the beginning of this syllabus when CSEC Add Maths was started from 2012 until 2016. And in this second video, we looked at the next 5 years of paper 2s from 2017 until 2022. Don't forget to look at the description down below where we have outlined the order to follow the entire CSEC Maths syllabus so that you can get a better understanding.